In this video, we're going to solve for x in the following equation. So when I look at this equation and I want to solve for x, my temptation is just to rearrange and try and isolate for x. But what jumps out at me here is this x squared term. And the fact that we have both an x squared term, an x term, and a constant term, I know that I can't just isolate for x. So what I want to do is to rearrange this and get it in my special form. And this special form allows me to choose the best technique to solve for x. And that special form is 0 equals ax squared plus bx plus c. So let's do that. So 0 equals 9x squared plus 12x minus 5. And from this point now, I have a number of ways I can solve this. But what I'm going to use in this case is I'm going to use my factoring technique. So a is equal to 9, b is equal to 12, and c is equal to minus 5. So the product, which is a times c, is minus 45. And the sum, which is the b term, is 12. So I need to think of two numbers that multiply to give me negative 45, but add to give me 12. And those two numbers would be 15 and minus 3. So I'm going to come down here and apply decomposition. So we have 9x squared plus 15x minus 3x minus 5. And now I'm going to factor out the highest common factor from the first two terms. So that's 3x, and that's going to leave me with 3x plus 5. And the highest common factor of the second two terms is 1, but what I notice is the signs here are both positive, so I have to factor out minus 1. So we have 3x plus 5. And here's my feel-good moment, since both these binomials are the same. So therefore I can factor out that binomial to get 3x plus 5 and 3x minus 1. And because this equation equals 0, what I can then do is say case 1 is 3x plus 5 equals 0. So 3x equals minus 5, and x is equal to minus 5 over 3. In case 2, 3x minus 1 equals 0. 3x equals plus 1, x equals 1 over 3. Now the temptation here might be to get your calculator out and give me the decimal value of these, but there's no need. Reduced fractions are perfectly acceptable whether they're in proper form or improper form.